Greetings everyone. I am Kritika Pawan Korimutha, roll number 68 from SY B.Tech Electrical Engineering, studying at MVP Samaj KBT College of Engineering Nashik. Today I'll be presenting my project on design of on-grid solar PV system for household in Nashik, which is guided by Professor Prasad Joshi sir. Okay, so we are together going to learn how to design this on-grid solar PV system. To begin with, I collected electricity bill data of each month of a year, which I further added for a year calculation from a household in Nashik. The total consumption was 2676 units per year. So now let's see the design calculations. As suggested by our professor, I used a 10-month average method to make the design more accurate. Dividing the total by 10 gives an average monthly consumption of 267.6 units. And further, if we divide that by 30, it gives an average daily use of about 8.9 units per day. So now further we'll see how system calculations are done. Here are a few assumptions which you can see on your screen. So now using this daily consumption, I calculated the required PV system size. Okay. So the formula to calculate the PV system size is the daily demand that we had calculated before, and we can divide it by solar irrigation multiplied by performance ratio. So for Nashik, the average solar irrigation is 4.5 kilowatt per hour per square meter per day, and the system performance ratio is 0.75 as the table shows. Now let's substitute these values into the formula I had said. So we will get 2.64 kilowatt. So the required system size is about 2.64 kilowatt. So next I calculated 440 watt monocrystalline solar panel for their high efficiency to meet the total of 2.64 kilowatt. 2.64 divided by 0.44 gives us the number of panels we are going to require. So hence the system will have 6 solar panels, each rated at 440 watts, giving a total installed capacity of 2.64 kilowatt peak. We also need to calculate the expected energy generation, right? So the expected annual energy generation is calculated by a certain formula. The system size into irrigation into 365, which are the days, into performance ratio. So after substituting everything, we get 3252. That is 3252 kilowatts per kilowatt hours per year. So this is the annual energy generation. So the system will generate approximately 3250 units annually, which is sufficient to make the household's energy needs. We have some components that we have used or we can use, which is 6 solar panels, which will be 440 watt, a 3 kilowatt on grid inverter, mounting structures, DC and AC cables, protection devices, which is MCBs, SPDs, and earthing, a bi-directional net meter, and lighting protection. Together, these components ensure safe and efficient operation. So now let's see how I calculated the inverter criteria for selection. So for inverter selection, a 3 kilowatt on-grid inverter is ideal because it matches the system size and offers about 95% efficiency with advanced MPPT control. The total cost of installation is about 1.71 lakhs. We also calculated the annual saving of about 39,000 gives a simple payback period of approximately 4.4 years. In addition, the system reduces about 2.7 tons of carbon dioxide emissions per year, helping protect the environment. So now let's study the block diagram. I have given two pictures. One is my handwritten and one is like I have made it. So you can clearly see the block diagram. The block diagram shows the proper flow, which is the solar panels, DC-BC, inverters, AC-DB, generation meter, net meter, grid and house, and all the workflow which is going to happen after the installation. When solar energy is available, it powers the house directly and sends excess electricity to the grid, as we know. So, in conclusion, to conclude, this 2.64 kilowatt on grid solar PV system is technically sound. It technically sounds economically flexible and environmentally stable. It meets the household electricity demand, reduces energy bills, and contribute to a greener future. I hope you enjoyed watching this and understood how this energy flow or the system is going to work. So, thank you for watching.